Hi, and welcome to Module 7, Managing Data. In this module, and we're going to split up in a couple parts, we're going to focus on the importance of data within the organization. Ultimately, what information systems is about the data. It's about delivering the timely data in a timely fashion to the individual stakeholders so that they can make decisions. And ultimately, we call that information, as we mentioned in a previous set of slides. So everything that we're going to talk about will focus on how do we move data appropriately, where does it reside, and what are the different types of ways that information technology works to actually make this happen. So when we talk about managing information resources, we are talking about managing the data and ultimately managing information because it is about transforming that data to information. And most corporate databases are well structured, carefully defined, they're controlled by the IS department. There is this hierarchical control. Sometimes that's good, sometimes that's bad. In other cases, you have a fragmented approach where individual departments have their own databases, and when you try and incorporate that data because it's critical to other processes, you run into the issue that you can't do it easily because they're using a database that is not standard, or they're using data that nobody understands, and there's no rhyme or reason to how they develop that. So as IS evolved, we now focus on, okay, information. It's any digital asset within the organization. And with that, we now create these three different levels. We create just the notion of data, which are facts which are devoid of any meaning or intent, information, which is data within context, and then we've wrapped it into this thing as knowledge, which is information with pure direction and intent. It really needs both there. So you create these knowledge bases. We'll talk about those as opposed to just a static report, which is really information which is built upon data. All of them will have a data component. Two of them will be an information component, and knowledge is really what the holy grail is for any organization. Corporate databases are still the major IS department responsibility. I mean, basically, if you have a database within an organization, it's controlled by the IT department. If it's a smaller database with smaller subsets of data, they still may be very critical, but they may be owned by smaller departments. So marketing may have their own email list that they want, or so a subset of customers that they've manipulated in some way. Finance may have some. If you're in a healthcare company, you may have data from the federal government or from the state that basically provides you with demographic data for certain diseases that may not be collected by the IS department or may not be centralized. Sometimes you may have different models, database models. So we'll talk about object models versus relational models as two key ones. You may have data in data warehouses, which is a fully aggregate data. Now, the problem with data warehouses is that a lot of times people say, oh, we have our data in the data warehouse. And that's great, but if you really don't know what is in there, or you cannot get the information you need, it's really not a data warehouse, it's a data repository. The real difference between a data warehouse and a data repository is that the data warehouse should really have not only all of the data, but the data should be cleansed in some fashion, and then eventually we can create some subsets, and it's clearly delineated that this is for analytical processing, not just for report retrieval. There's really needs to be a component that says we are going to do things a little bit faster, better, and provide better analytics. Another example would be a CRM system where it has its own database, and that data may be centralized to the functions of customer relationship, but generally they're easier to pull out and aggregate with other databases. Information can be in the form of documents, like electronic or paper. We may want to store that. We'll talk about document management and content management. Knowledge management is really a key to exploiting the intellectual assets, where you want to try and collect all of the information from individuals within your organization and basically have it in a repository so that if the employee leaves, that information doesn't leave with them. It gets to the whole notion of, you'll see people who, I don't want to tell someone else how I do my job because that's job security. You're going to get into some contentions with providing this data in a repository, and there are different ways, and there are multiple theories that can actually talk about when people will or won't contribute to a knowledge repository. And those are key things for IS departments as well as other departments that want to make use of a knowledge repository. Information resources need to be managed. We need to really clearly understand what the information is. It's great to have everything, but when you have everything, you can have a mess. So it needs to be somewhat structured, and I use the word somewhat because there's always this notion that if you're going to aggregate all this data, it always has to be perfectly structured. The reality is it never is that way. There is a good structure, there's a good foundation, but there may be other pieces that are not so structured that are kind of evolving or adapting as the business changes. So there's a notion of a three-level database model. It's very, very simple. The first level is basically a conceptual model. It's not really concerned with how the data is physically stored or what data is going to be used. We're just going to basically say that we have a database for our customers, and we might ask things like, what are we going to contain, what is going to be contained in this database? It will be the customer demographic. It will be the basic customer information. Do we store orders, or do we put that in another database? For inventory, that would obviously be another database. Now, when I use the word database, you got to be careful, because if you're knowledgeable in databases, you may say, well, that's a separate schema, not a separate database. We're talking about models, and so as the organization evolves, you may have separate databases, physical databases, that have their own sets of data that are different. You may also have them contained within a single database structure, which actually has inventory and customers together, but in separate schemas. And you may also have all that information inside of a single schema. So I'm just going to ask that you kind of bear with me on this for a little bit, to just say that, look, the level one is a conceptual model of how our data is organized and nothing else. When we get to level two, we're talking about the technical view of the database. Now we're starting to get into a little bit more of the models of what are the fields going to look like? What are the tables going to look like? How do I set up my foreign keys and private keys, which are connectors that says a user or a customer has an ID, and that ID gets used through anywhere within our system that is associated with that customer. So that might be a level two. And then a level three is actually we get into the physical storage. How are we physically representing this database? Where is the data going to be stored? How do we get at it? Are there any pointers and flags? So that the end user doesn't care at this point of how that's stored or how the physical architecture handles the data, just that it can get it. The four data models, now when we talk about data models, we're talking about how we represent ultimately the data. And here we're basically saying that we're going to organize the data in a particular way that is maybe dependent on each other or independent of each other, and how we're going to represent it ultimately within the database. The first model is called the hierarchical model, and it structures the data so that each element is subordinate to another, very, very strict parent-child. If you did a lot in computer science, or if you had any type of a computer science background, you'd know this as a linked list, where you have one item which is connected to another item, which is connected to another item. They're all linked together. And you have this notion of parent-child, and you can think of it as a tree where you have a parent node and then some children nodes, pieces of data that are connected to that. We don't really use that model. There are ways to use that model, and there are times to use that model. But in a lot of the applications of databases right now, that's not a model that you're going to be focused on. Another one is a network model where relationships are stored with pointers with data. This is, again, another level where you can have each data item to have more than one parent. Again, these are more, they're a bit conceptual and not so practical in terms of the way you might be used to databases at this level, or especially from a management perspective. You don't necessarily care about this.